CRO, cathode ray oscilloscope. So you must have heard about the cathode ray oscilloscope. So it is having basically a CRT monitor. So in that CRT monitor, you will display the signal. Okay, you will display the signal. So when we are giving one signal, that signal will be visualized in that cathode ray oscilloscope. So from the visual analysis we can do, just like voltmeter will give you the information how much voltage is there, that will give you the information what is peak to peak voltage. But in the CRO we can visualize the signal, and from that also, from that CRO screen, from the display only we can calculate the what is the peak to peak value, or what is the voltage of that signal, amplitude of the signal, frequency of the signal. All these things we can calculate from that only. So in our first experiment, the measurement, you have to you will be acquainted with the measurement, using how to do the measurements using the CRO. That is basically your voltage measurement and frequency measurement. Obviously frequency measurement is there, means obviously it is related to your time period. If you calculate the time period of a signal, then you can calculate the frequency of that signal. So if this so in this experiment, one objective of this experiment is to measure the voltage, time period and frequency of different type of signals, so that you will be acquainted how to generate different signal, how to use the CRO for measuring those parameters. And in the next objective, you will measure the frequency and phase of different signals. If two signals are there in the available, and one signal is known to you, so from the known signal frequency, you can calculate the other signal using the CRO. That is also one application of CRO, where we can use the CRO to know the frequency of a unknown signal. When other signal is available whose frequency is known to you. So unknown frequency can be calculated from the CRO. That is, a pattern will be generated, that is called the Lissajous pattern. Using that pattern we can calculate the frequency, unknown frequency. And also if you are providing two signals, if two signals are available, so we can measure the phase difference of that signal also in the CRO. So this two part you have to do in the experiment number 1. So as physically CRO looks like this. Okay, physical appearance of CRO, if you are in the hardware lab, if you are using, physically the CRO looks like this. Okay, and this is your function generator. This one is the function generator. So this CRO, it is having a screen. Okay, this is the CRO and this is the function generator. So, and as we know, the function generator here, it is, if you look this function generator here, the 3 knobs are there for different type of signal, like sinusoidal signal, triangular signal, and your square signal. So if you press the corresponding button, that corresponding signal will be generated, and here different knobs are there where we can adjust the frequency and amplitude of the signal. So here the probe will be connected. Okay, that is a connecting wire that is shown in the multi-sim. Here we will use the probe. So that probe will be connected in from this, and the signal can be connected to other probes. That is in the CRO also same probes are there. So if you want to connect this function generator to this CRO, then we will have to use this probe. So separate specific probes are there. So electronic probes are there, so that within that probe or that wire we can connect the devices. So when we generate the signal here, we can display that signal here. So basically, whatever the CRO we are using in the lab, all are dual channels in the CRO. So dual channel means there are 2 channels. Here one channel, channel 1, this is channel 2. That means simultaneously we can give 2 signals to the CRO and we can visualize 2 signals in the CRO. So, and these are here one knob is there where we can use that knob for changing the voltage. One knob is there where we can use the time period. So this time period knob is common to both the channel, and this voltage knob is different for 2 voltage knobs are there. So which are one is for the channel 1 and another is for the channel 2. So there are various options are there. Here also one knob is there where we can control whether we want to see the AC or whether we want to see the DC also. So there are various options are there where we can adjust the appearance of that signal. So the same signal with different frequency we can observe, we can vary the frequency, we can make the amplitude fixed, or we can vary the amplitude by keeping the frequency fixed. So various options are there. So when we connect that, this is the symbolical representation in the multi-sim. This is already, you know, this sinusoidal waveform display screen is there. That means it is the CRO. Here this is channel A and channel B. The two channels, whatever I have shown you in this channel 1 and channel 2. So in the multi-sim we will have this A and B channel. And in one channel you can give one signal. If you want to simultaneously visualize two signals, then we can use another port also you can use. And after connecting this, when you display that, actually physically when in the we display the signal in the CRO, this kind of waveform in the blue screen, a bright waveform you can observe. And here we can clearly it is visualized that the this grid structure of the screen. So from the grid structure of the screen, you just calculate the number of blocks, number of box covered from peak to peak, number of boxes covered from peak to peak. Like here, how many boxes are covered? Is it clearly visible to you? 1, 2, 3, 4, 5, 6. 6 complete blocks is there. So 6 complete blocks are covered from peak to peak. So this 6, if you are calculating 6 peak to peak voltage, then 6 division we have to consider. And how much division we have adjusted in the CRO knob? Like if this is given volts per division, in your here in the voltage knob there are volts per division readings are there. This adjustment meter is there. So how much volts per division we have set? Like suppose for 1 volt, 1 division we have taken 1 volt per division. That means it indicates that one box indicates 1 volt. Like peak to peak 6 boxes are covered. So we will have, suppose we have the setting that 1 volt per division. Suppose we have 1 volt per division. So what will be the peak to peak voltage? 6 volt will be the peak to peak voltage because 1 volts per division. So we have 6 division. Likewise, suppose it is 2 volts per division, the knob is set. So in that case, we will have, so for each division, if it is 2 volt, when 6 division is covered, means the voltage is 12 volt. So peak to peak voltage is 12 volt. If you want to just calculate the, from this middle one is for the 0 level. So from the 0 to suppose peak, 1 peak if you want to calculate, then this will be the half of this. So this only 1 peak if you are calculating, then 3 division you have to consider. So when we practically see the CRO, this in between this big boxes, there are very small divisions are there. Like each distance is divided into 5 more divisions. That means each small, it is not visualized here. So inside the big division, like if it is the big division, so inside that 5 small divisions are there. That means each small division is 0.2, 0.2 we have to consider. So for this particular signal, it is from peak to peak completely 6 division. Sometimes you will have the signal which will not have the complete boxes will be covered. Suppose 3 big division is covered and 2 small division is covered. 3 big division and 2 small division. Then we have to consider how much division. This will be 3 point. This will be 0.2. So 3.4 division. 3.4 division you have to consider. Accordingly, you have to calculate the voltage. If it is 2 volts per division, then you just multiply 2 volts per division. So it will be 6.8 volt. So in this way also we can calculate the volts per division. So when we, yes.
Ma'am, can you explain what is the division you are referring?
Actually, in CRO screen, when you physically see the CRO screen, like in multisim, actually it is in the multisim, this kind of black type of screen is visualized. Okay, so can you see here? This is a big division. Okay, in between this small divisions are also there. This grid structure is again subdivided into very small lines. So from this one point to another point, 5 divisions are there, just like your scale. From in 1 centimeter, we will have 10 divisions. Like here, from one box, 5 small divisions are there. Means a one small division means 0.2 volt, 0.2 big division. So suppose this is covering 2 complete division and 3 small division. Then how much division we will consider? 2.6 division we will consider. So finding the voltage. When you use this, it will be clear. Okay. So it may not be that always all complete division we will get. Sometimes in the fraction also we will get. Okay. Is there any doubt? Likewise, time period also. This scale, whatever you are getting, is it visible? This scale, whatever you are getting, here it is only the big divisions are shown, but in between this again small divisions are there. So that small divisions also you have to consider when you calculate the time period and your amplitude. So when you will do that experiment, it will be clear. So calculate the number of division and you just see the voltage knob and the time period knob, how much it is in which position your knob is set. Like suppose for here 3 divisions per cycle, for it is calculation of your time period. That means from one cycle to another cycle 3 complete divisions are covered as per this example. Okay, and here it is given that 1 millisecond per division, 1 millisecond per division the knob is set. That means you have to calculate the time period 1 millisecond per division into 3 division. So obviously 3 millisecond. Okay, 3 millisecond in one cycle. So the time period of this signal is 3 millisecond. So you have to calculate the frequency. 1 by time period will be your frequency. Yes.
Ma'am, can you explain 3 division per cycle?
You just see this diagram. Okay, so for complete cycle, first of all you have to this middle one is the reference level. So which one is your complete cycle? This from this point to this point, this is just complete cycle. Okay, if you see how much division is covered, this division is completely covered, this division is completely covered. Okay, and the third division is this one. So little bit it is extended from this side, and this is less from this side, and this is extended from this side. So if you completely combine all this, approximately completely 3 complete divisions are covered for one cycle. If you take one cycle, then 3 big divisions are covered. Are you getting?
Yes, ma'am.
Division means this is 1, 2, and 3. 3 divisions are covered. 1, 2, and 3. 3 divisions are covered. So if it is 3 division, and this is the time period knob or the time period of the in the CRO, the physical knob is there where you can adjust the time period. That means adjust the frequency. So here the knob is at the position of 1 millisecond. It means this is 1 millisecond per division. So what it indicates? Your in this example, as per the setting of this knob, one division is indicating 1 millisecond. So what is the overall time period of this? 3 millisecond, 3 divisions are there and 1 millisecond per division. So you just multiply this 3 division into 1 millisecond per division. So division get cancelled out. It will be 3 millisecond. So the time period of this signal is 3 millisecond. Time period is 3 millisecond. Okay, 3 millisecond. So you got the time period.
Ma'am, can you explain this once again?
This
connection broke.
yeah.
Can you explain this point?
Okay. So this is the for this signal. Suppose you want to calculate the frequency. So frequency will be 1 by time period. So we need to calculate the time period of this signal. So what will be the time period? How to calculate the time period? So time period means one complete cycle, how much time it is taking, that is the time period. So for calculating the time period, you just observe this complete cycle. One complete cycle is covering 3 complete division. So 3 division in one cycle we are having 3 division. So 3 division means here the knob is set at the 1 millisecond. So that means it is 1 millisecond per division. So 3 division into 1 millisecond per division. So that it will be 3 millisecond. So time period is now 3 millisecond. So frequency will be 1 by 3 millisecond, whatever it is value is coming, that you need to calculate. That will be the frequency. Okay. So in this way, you can calculate the frequency of the signal from the CRO. Likewise, amplitude, as we have explained, amplitude you can calculate either peak value of, we can calculate that is 0 to peak, or peak to peak means this peak to this peak. This is the peak to peak value. So in a similar manner, you can calculate the amplitude and frequency for any signal. Okay, for any signal you can calculate. So this is the first objective of your experiment. You have to calculate the frequency and amplitude of the signal. So whenever we represent the signal for calculating this frequency or amplitude, this signal representation is the value of the signal or the voltage of the signal with respect to time we are plotting the signal and we are observing. Okay. But in the second objective of your experiment, that is measurement of your unknown frequency and phase of a signal by using the Lissajous pattern. Okay, so that is another kind of representation of the signals in the CRO screen. So in CRO screen, actually, whenever we provide two signals, okay, one is known, another is unknown. So two signals if you provide in the CRO in both the channel A and channel B, if you provide two signals, and we are comparing these two signals, that means we are superimposing those two signals. And if you plot a graph, that is usually we plot a graph that is time versus your amplitude. Amplitude means that is the voltage. Time versus voltage, we are plotting this signal. Okay, suppose this is your signal 1. Another is suppose the signal 2. Suppose this is your signal 2. If you superimpose both the signal, that means both the axis, the reference axis of both the signal, if we align, and you just there is an option of your plotting that Lissajous pattern in your CRO screen. So in the CRO screen, if you want to plot the Lissajous pattern means we will plot the signals, that is voltage versus voltage of signal 1, versus voltage of signal 2. When we take the graph like this, both the taking in the both axes the voltage of both the signal. In that case, we will get a different kind of pattern. It may be pattern like with this, it may be pattern like this, a single vertical line or horizontal, this is tilted line, or the signal may be this kind of pattern. Various type of pattern we will get according to the frequency and phase or amplitude of the signal. So these are called as a Lissajous pattern. These are called as a Lissajous pattern. So Lissajous pattern is the signal. We are in that case we are representing two signals simultaneously, and we are plotting the graph, that is voltage of amplitude of one signal versus amplitude of other signal. And from that pattern, a lots of information can be obtained. So as per our experiment, we will calculate the frequency of the one signal based on the frequency of other signal, and we will calculate the phase difference between both the signals. So when we connect in this way, we will get this type of pattern. Actually in the real, physically CRO, this kind of bright structure is often always not, it is not always ellipse, it may be any other line, it may be any other type of Lissajous pattern. So this is the one of the example it is shown. So in real CRO, it is looks like this, and in your multi-sim CRO, it will looks like this. So from this you have to capture some information. So these are various Lissajous pattern when we obtain, means when we take the same frequency for both the signal. When we are providing two signals and you are taking the same frequency for both the signal. Signal 1 is having also the same frequency, signal 2 also having the same frequency. But there is phase difference between two signals. So in that case, which kind of pattern we will obtain? Like if it is the phase difference is 0, then we will get a single tilted line towards the right side. That is in the if it is 45-degree phase difference is there, we will get a ellipse structure. If it is 90-degree phase shift is there, we will get a circle. So likewise, as per the phase difference, we will obtain different type of patterns. Okay. And if the frequency is different, like suppose the frequency of one signal is 10 hertz, another signal is suppose 20 hertz. In that case, this kind of pattern we will obtain. So one frequency is unknown to you. So in that case, we don't know the frequency, but we can calculate. Once we got the Lissajous pattern, we can calculate the frequency. So how to calculate the frequency? Just see here. See here, there is a formula called the number of times of tangent touches the top bottom, number of times tangent touches the either side in the vertical direction, or we can say number of horizontal tangency divided by number of vertical tangency. This ratio will be equivalent to the frequency of Y signal by frequency of X signal. Okay, so for example, suppose this kind of structure, suppose just verify the formula. Suppose we are getting a Lissajous pattern like a circle. So what will be the number of your tangency? Vertically, you just draw one line. So suppose vertically, if you vertically draw one line, and horizontally you just draw one line by touching this pattern. So when you draw a line, you just horizontally it touches only in one point. Likewise, vertically it touches in one point. Okay. So here your Fy by Fx. This is vertical number of horizontal tangency, means horizontally how many times it is touching the pattern. So here only one time, and vertically also it is one time. So the ratio is 1. That means it indicates that both the frequency are same. Okay. Suppose you are having a pattern like this. Suppose you are having a pattern like this. So in the horizontal tangency and vertical tangency, if you say, in that case horizontally 2 times it is touching. So horizontal tangency is 2 and vertical tangency is in one place it is touching the pattern. So it is 2 by 1. So we can say this Fy by Fx is 2 by 1. That means your Fy will be twice of Fx. One is your known frequency, another is your unknown frequency. So if the structure is not complete structure, this kind of structure if you are getting, means here the tangency when you calculate, if we are calculating this type of tangency, so that means what it indicates, it is number 1 time it is touching, number 2 times it is touching, and it is an open side. In the open side it is considered as half. That means total number of horizontal tangency is 2 plus 1, 3, 3 and half. So 3.5 is your horizontal tangency. And what is your vertical tangency? If you take the vertical tangency here, so then just make a straight line. So only in one point the vertical tangency we are getting. Or if you are plotting the vertical line in this side. So in that case you are having this is half plus half 1. So it is similar. Either you can draw the tangency here or you can draw the tangent line here. So you are getting the vertical tangency, that is 1. So this Fy by Fx, that is equal to 3.5 by 1. So accordingly you have to calculate the, yes?
Ma'am, 3.5 or 2.5?
3.5, sorry, 2.5, sorry. Yeah, right. It is 2.5. This is 1, 2. So this is one tangency, this is one tangency, this is half tangency. So 2.5 by 1. So your Fy is equal to 2.5 times of Fx. Okay. So in this way you can calculate, if you know one frequency, we can calculate the unknown frequency from the Lissajous pattern. So you can vary the different frequency of one signal and you can obtain various type of Lissajous pattern and you can note in your file. As much as possible, 6 to 7 or more also you can plot. Then one more part of that second objective is your phase measurement. Okay, how to measure the phase difference between the two signals. So here for the phase measurement experiment, we have to make a setup like one signal we have given, one RC circuit we have connected. So once the RC circuit is connected, at the output side obviously the signal we are getting having a different phase shift, So one signal directly we have taken as the input signal in one channel, and after passing through the RC circuit, another considered as the second signal. So for that case, just we can verify easily that for this circuit, if you calculate the theoretically what is the phase difference of both the signal, in that case theoretical calculation, this phi will be your tan inverse omega RC. Omega is your angular frequency, that is your 2 pi f. So what is the frequency of the input signal what we have taken, that frequency into the resistance value and capacitance value. So by putting this theoretically, what is the phase difference that we can calculate, and we can verify whether this theoretical frequency is closer to your practical frequency or not. So this practically, when you got the Lissajous pattern, that means here we have to consider the same frequency of both the signal. If the both the signal are same frequency, we will get this elliptical structure. It is only having some phase difference. So this kind of elliptical structure we will get. So from that you can take the either you can take this distance, this two distance, or take the theta is equal to sine inverse A by B. This will give you the phase difference. Or you can take this from this point to this point. What is the distance? You can calculate. That is number of divisions you can calculate. That will be the distance means what? Number of division you can calculate. And from this point to this point, what is the number of division it is covering? That you can calculate. Thus, both the ratio will be same because this is the reference horizontal line we are taking. So either you can consider 1/2, or if it is difficult to calculate visualizing the ellipse in the multisim software, it is very small ellipse is there. So in that case, you can calculate from peak to peak also you can calculate and take the ratio. That will be giving you the phase difference between two signals. So this much of experiment you have to perform in your first experiment. So in the first experiment, you have to first of all you apply the signals from the function generator to the CRO, measure the frequency, measure the amplitude by varying the signal type. Take the sinusoidal signal, triangular signal, then your square wave signal. 3 type of signal we can generate, and we can measure the voltage, amplitude, all these things, and then consider the Lissajous pattern. Some Lissajous pattern, you just calculate the frequency, and one experiment you can do for the phase measurement. This for this experiment. Okay. So if you have any kind of doubt, then you can ask, or in multisim how it will be performed. First of all, you have to download the multisim, and it should be in your laptop. So if anybody is not having the multisim, so before the next class, you just inform us so that we can arrange for you.
Ma'am.
Yes.
Ma'am.
Yes.
Ma'am, last one you have explained. I have doubt in it.
Which one? Is this on phase measurement?
Yes, ma'am. Ellipse type.
Yeah. In this ellipse structure, like suppose, yeah. In this case, suppose this kind of ellipse structure we are getting. When you connect both the in both the channel, you provide the signals. You got a structure like this. Okay. So here you have to calculate the phase difference from this Lissajous pattern. So from this peak to peak, that means this peak to this peak, how much distance it is covering? Just calculate 1, 2, 3, 4, 5, 6 complete division. Okay. Another distance we can calculate where the ellipse intersect that axis. That means this distance to this distance, this one. Okay. So how much the distance? You just complete 1, 2, 3, and 4. Okay. So total 4 division it is completing, and this is 6 division. Okay. 1, 2, 3, 4, 5, 6. So what will be the ratio? That will be sine inverse as per the formula. This will be how much? Sine inverse A by B. So the value will be here sine inverse. This is 4 division, 4 by 6. This will give you the phase difference between the two signals. Okay.
Ma'am, another method. Ma'am, another method you have explained now.
Another method means only this one, na? This one you are asking. So here only half if you are considering.
Yes, ma'am.
Yeah, if you are considering the half, then you just take this in the half. If you are taking, how much distance it is taking? In place it is 4, in place it is only 1 and 2. From this point to this point it is 2 division, and from this point to this point we will calculate that is 3 division. 1, 2, 3. So just here it is clearly shown. That's why it is possible. But if when you do the hardware experiment, this kind of waveform you will get. So it is difficult to have that position. So we generally take the peak to peak value also. As per your convenience, you can take. The ratio you have to consider. So the ratio will always be same. Either you take the half or full.
Okay, ma'am.
Ma'am,
Yes.
ma'am, I have doubt in phase. And phase diagram, I have a doubt.
Yes.
I mean phase diagram. Last. I mean here the terminal will connect after capacitor, or it will before capacitor.
See, in this RC circuit, what is the output? Always output you have to consider across the load. Okay. So here the load will be your capacitor, here the load will be. So you just see here, at this point we are getting the signal, one signal. At this point you are taking another one more signal. Here first signal, suppose here we are taking the second signal, and the second terminals are grounded. So one signal we are before the resistor, another is after the resistor we are taking. Across the capacitor, with respect to the ground only we are taking. That means with respect to this voltage we are taking as the signal. Suppose V2. Suppose this is your V1. So V2 is, as we are taking here, means what? With respect to ground we are taking the voltage. So across the capacitor we are taking the voltage.
Yes, ma'am. Clear. Yes, ma'am. Clear.
Yeah.
मैम
So yes.
मैम वो पीक वैल्यू मेजर कैसे करते वो सीखना था.
कौन सा पीक वैल्यू?
वो सर ने पढ़ाया था ना ऑसिलोस्कोप में.
ऑसिलोस्कोप में.
हाँ, वो जानना था.
ऑसिलोस्कोप में हम लोग इस टाइप का वेवफॉर्म आएगा ना, वी आर गेटिंग द वेवफॉर्म लाइक दिस. ठीक है. तो पीक वैल्यू मीन्स आइदर यू आर कैलकुलेटिंग, जब हम लोग थ्योरी में पढ़ेंगे, ओके, थ्योरी व्हेन यू विल यूज द कॉन्सेप्ट इन थ्योरी, आइदर यू विल बी गिवन suppose BMP, that means BM peak means only one, it is, if this is the signal, okay, this will be your BM peak only from with respect to 0, what is the voltage. And if you are taking BM peak to peak means from this peak to this peak you are having the voltage that you need to calculate. So if you are calculating peak to peak voltage, that means you have to consider from this point to this point how much division it is covering. So here it is 1, 2, 3, 4, 5, 6. 6 division it is covering from peak to peak. 6 division, and you have to observe the voltage now where it is set. So here, for example, here it is 50 millivolt per division. So 6 division we are having into 50 millivolt per division. So division can cancel out. We will have the 5 into 6, 300 millivolt. That means peak to peak voltage of this waveform is 300 millivolt. Okay, clear?
Ma'am, how we will download the software?
Student version is available, I think, in the net. You can go through that and you can download it.
Ma'am, it is showing that we have
Ma'am,
to
it is
pay
in trial
for it.
period only for 15 days.
Only for 15 days it is showing.
Yes, and after that we have to pay for it.
Okay.
Okay, so in that case we will check, means if we have any key with our department, and then we'll try, means if we can share that.
Yeah, we'll inform you.
Yeah. Okay.
You know.
So if anything else regarding your multi-sim operation or anything if you require, then you can ask Raghavendra sir. Otherwise, if you will be ready with your software and all the theory, whatever we have discussed today, you will be get ready with that theory. So the next lab you have to do the experiment.
Ma'am,
Okay,
please
ma'am.
upload all the files.
Okay, lab manual is already uploaded. The PPT we will
Ma'am,
upload.
PPT.
Okay, we will upload. Okay.
And regarding that lab write-up, means that lab journal, so you can just follow this thing. This one you can just follow. Okay. So there are a total 7 different fields are there. So you have to fill up those different fields, and you have to you can just scan that particular A4 sheet and send that. Okay. And we will upload this file also in that file section.
Sir, we have to write it in a notebook, or we can do it on MS Word.
It is
The
better
file.
if you write it on an A4 sheet, means by pen and paper, and take a photograph of that
Okay,
and
sir.
send it to us. Okay.
Yes.
Okay.
Sir, where we have to send?
So we can we create any another file, madam, Pragadas madam? Any folder or something for these teams?
Sir, Nilanjan
Yes.
sir?
Yes.
Sir,
So yeah.
yeah, sir, what you were asking?
Yeah, the students are asking that where can they send that lab write-up? So
Sir,
can they
actually,
just upload? Yeah.
no, sir, actually, the next lab they will perform now.
Okay.
After they're able to simulate in multi-sim, they will download it and they will perform this experiment in the next lab.
Okay.
So after completing the lab, they will submit it. We will create one assignment there so that it will be better. Otherwise, arbitrarily, if they will post, then it will be difficult to accumulate all these things.
Right.
So we will create one assignment after the completion of the lab in the next class.
Okay. So they can submit their
Ma'am,
assignment there, right?
Yes, sir.
Okay.
So for experiment one, we will create
Ma'am,
every experiment. We will create one assignment so that it will be easier to evaluation.
Okay.
ma'am, means today we have not to.
No, today you don't have
write.
to write. You just first get ready with the multisim.
With the software.
And, yeah, with the software. Then you just go for the theory part, whatever it is associated with the first experiment. And in the next lab only, you just, if it is possible, actually next lab is, I think it is holiday, sir, 14th of January.
Okay.
So you just get ready with all the write-off. Okay, lab manual is already provided to you. So you just get ready with the write-off of your thing, just excluding the observation part in the table. In the tabular form, you can keep it blank, and other part you can complete. And in the next class, after doing the experiment, directly you can put your values of the observation in your table, and the same day you can upload your file, because we will not have much time. So next lab we will have the holiday, so it will be difficult again for next class we will have to perform the experiments.
Ma'am, we have to start the experiment by today or after 14.
If you are able to do, then you can do it.
Yes,
Okay?
if you can download the software and you can start, then
and you
please start doing that.
Actually everything is given in the lab manual. You can try it so that after 14th in the next lab class you will just show the results to us. If time will permit, then second experiment we can start also.
Okay, sir. And sir, can you, sir, where will you post? What do we have to do regarding the software? Because it is showing that this one is only for trial.
Yeah, we'll look after this, which software we have to download, we will inform.
Okay, sir.
Okay.
Ma'am, one more question. Ma'am,
Yes.
if we will not be able to download the software, then what I have to do?
Then we will
Ma'am,
provide
can we use another software?
another software. Means which software?
If we find any other software online for this, can we use that?
It is better if you do the multi-sim, because
Actually, you can see that in multisim there are multiple components. Means the components which we are going to use in this laboratory, all of them are available in multisim. So it is better if we can try this multi-sim software.
Sir,
and we will-
until the multi-sim problem is solved, until then,
Yes.
if we can do it on another.
Yeah, for your learning purpose, you can, if you get anything else for your learning purpose, you can start checking that. I guess that is okay, madam?
Yes,
Because
yes, sir.
until
Yes,
until
yes.
they get that.
And
multi-sim.
if you have connection with your seniors, then you can also, they will also guide you how they have done how they have downloaded the softwares. They can also guide you.
Okay, ma'am.
Ma'am, if I not able to download it by computer laptop, then what is the another way I can do it?
In that case, we will have, sir, I think we can give the access to lab system, no?
Yes, yes. So
Yeah.
at first you try, because
Yeah.
this multi-sim, I think it requires very limit, means for that actually you don't need any higher specification in your laptop, so you can access that. So at first you try to download that software in your laptop or your desktop and try to access that, because there are multiple components, as Raghavendra ji has shown that those things to you. So you can you could see that there are multiple components. So at first you should try, means which component is for what purpose and how to use those components. So you can try those things. Okay, so at first you try to download that software and just go through, means you try to just solve one simple problem. Like what Raghavendra ji has shown, that you can just add up to different registers and just put 1 voltmeter or ammeter and just try to see that how much voltage is there or how much current is flowing. So these things you can just do at your home, and then yeah, means we can give you some experiments and you can solve those things. Is that fine?
Okay, sir.
Okay.
Okay, sir, then we can download the attendance list, and
Yes.
after that we can allow the students to leave.
Yeah, so regarding this attendance, just be careful, means we can take this attendance any point of the class. Okay, so just try to be present in that class throughout the class actually. So otherwise you will just miss the attendance. Okay.
Yes, ma'am. Ma'am, PPT upload कर दीजिए.
Sure.
Hello, ma'am.
Yes, sir.
Actually, just I want to show how to get Lisage's figure in this experiment. So it will be, I think, beneficial
Yes.
for a student for their practice purpose.
Yes,
if they
sir.
can
Yes,
see
sir.
how we can generate Lisage's figure in oscilloscope.
Yes,
Sure. That will be good.
Just hold, ma'am, 1 to 2 minutes.
Yeah, sure, please.
सर आप डाउनलोड कर लीजिए अटेंडेंस लिस्ट. निरंजन सर.
See that guy right
Okay.
there?
Yes, sir.
Whoa. See that guy right there? Looks like he's hit rock bottom. Well, that guy's actually me.
So students, pay attention, please. If you want to see the Lisage's pattern in your experiment, you will see we have used 2 function generator. So simply you can copy this function generator by pressing Ctrl+C and Ctrl+V. You may paste this component. Okay. Now you have to provide 2 input. So you will see your lab journal. This is the circuit diagram for the Lisage's pattern. I have used 20 Hertz 10 volt peak at the input side, and at other function generator, it is also 20 Hertz 10 volt. So you will also, actually ma'am has told that if the frequency will same and the amplitude will same, you will see the Lisage's pattern. Actually, this is the previous one. So you will aware that you will get a straight line, okay, if the frequency will same. So simply you have to click on B by A. So be careful. If Y by T is selected, you will not able to see the Lissajous figure. So you have to click on B by A. So you will able to see the Lissajous pattern. This is the straight line. So a straight line will only there if the frequency will same at the input side and output side, or the phase difference should be either 0 degree or 180 degree. So if you will use 180 degree phase shift, only the orientation of a straight line will change. Other you will get the straight line. If the frequency will mismatch, suppose that at function generator 2, we have kept the frequency 10. So you can see the Lissajous pattern. It is different from first Lissajous pattern. Okay. So I want to show you how to get the Lissajous pattern. Now, after the reading your lab journal, you can easily analyze the Lissajous figure, how you can get the circle, how you can get the straight line. For the circle, you know the phase difference between input and output signal. If the phase difference is 90 degree, you will get the circle Lissajous figure. So you can see in function generator, there is no facility to provide the phase degree. So for that purpose, you have to use in source, you have to click in source, and in signal voltage source, you have to select AC voltage. Now, okay. And in AC voltage, you can see by default voltage is 1 volt peak, frequency is 1 kilohertz. So you have to keep the frequency same. So we will keep it at 20 hertz. Voltage, peak voltage actually 10 volt peak. So I have changed. And in this, you can see the AC analysis phase. So you can change the phase degree also. So I am keeping it at 90. Okay. Now we will provide input and means at the one input of oscilloscope, we will connect using this. So disconnect from here, select this terminal, press delete button, and provide the input from this AC source. And now see the result, simulate this. Actually, frequency is 20 here. Actually, in function generator 2, that's why we have not got circle. Frequency should be same. Okay, phase difference is 0. So we have to change phase difference. Okay. Okay. Stop simulation and again start simulation. Just hold on. Actually, phase difference. Okay, the phase. Actually, we have provided AC phase analysis. You have to simply put the value in phase 90. Okay, that's right. It is showing now 20 hertz, 10 volt peak, and 90 degree phase shift. Now we start simulation. You can get the circle, and you can see here a circle is such figure. Why? Because the frequency is same of both the function generator and the phase difference is 90 degree. So we have got a circle, and if the frequency will same and the phase difference also same, you will get the straight line. Okay, that I was showing this. Okay, so now you can do yourself, and then if you will feel any problem, you may ask. Okay, ma'am. Any problem, students?
Sir, how will you change the frequency? Where? From where?
We may change frequency by double click on the component. Actually, in function generator, there is no facility to provide the phase angle. That's why we have used AC signal source. In AC signal source, you can change the phase degree also. Okay. That's why we have used AC source to show you the circle Lysage's pattern. But in experiment, when you will calculate the unknown frequency using the Lysage's pattern, in that case, function generator is sufficient. Suppose that I have kept it at 0 degree phase. Okay, then you will get a straight line. You can see. And for the calculation of unknown frequency, so suppose the channel 1 frequency as fx and channel 2 frequency fy. Okay, then using your lab journal, I think that is uploaded and you can see the formula. So how to calculate the unknown frequency? Simply that is fy equal to, just hold on, ht upon vt into fx. Horizontal tangency by vertical tangency into fx. So suppose that I have kept constant of channel 2, that is 20 hertz. Okay, and at input side we have kept 10 hertz. Press OK. Now see the Lysage's pattern and you can see the top line that is touching at both the end of this Lysage's pattern. So the HT value will be 2, and if you see the vertical tangency, so vertical line is touching at one end of this loop. So the value of Vt is 1 and HT is 2. And the fx means input frequency. So you can calculate, so 2 by 1 into fx. So 2 by 1 into 10, you will get 20 hertz. That is the output, that is the value of output signal. Suppose that I have kept the input frequency 5 hertz. Okay. Now see the pattern. Now you can see the top line, division line, that is touching at 4 end of this Lysage's pattern. 1, 2, 3, 4. So HT is 4 and VT is 1 because vertical line touching at only one end of this loop. So 4 upon 1 into input frequency 5. So 4 into 4, you will get 20 hertz. So this is the basic. You can calculate the output frequency or unknown frequency.
Sir.
Yes.
Hello.
Yes.
Sir, initially you use two functional generator and now you use one generator. So what is the difference?
Actually, you can perform using two function generator, but I was showing the circle, and if you will get circle in Lysage's figure only when the phase difference is 90 degree. Okay, But in function generator, there was no facility to provide the phase angle. That's why we have used this signal, actually AC signal. Okay, because in AC voltage source, you can change phase also. And from where we have got this? So we have got from this place source in signal voltage source, we have selected AC voltage.
Sir, means
Only
on removing the one function generator, there is no changes.
No any change will be there. Suppose that in this time you can see this type of pattern, and if we will remove this signal source and we will add function generator, the Lissajous figure will be same. I am showing you. So you can see we have used two function generator and input frequency we have used in AC voltage source, that signal. You can see there is no any changes in Lissajous figure. Okay, so it is your choice whether you can use function generator or AC voltage source. Okay, the value, if the value will same, then you can get same Lissajous figure. Okay, so now you can do the practice. Actually, if 15 days, I think that is also sufficient for your practice. Otherwise, we will provide you the terminal. Remotely you can do. But for practice purpose, if 15 days is the free license is giving, you may download and practice for 15 days. That is sufficient.
Sir, why should we use B by A instead of A by B? Can you explain it again?
Actually, channel B divided by channel A. And simply the orientation of Lissajous figure will change. Okay. So you can see when we have pressed A by B, then the Lissajous figure is actually like this.
Okay.
Any more question? Ma'am?
Sir, I have a question, but it's not about the simulator.
Yes, tell me.
Yeah, so while writing the lab record, do we have to maintain a book or we can do it on an A4?
I think you have to maintain a lab journal, written lab journal also for your future reference.
Right. So, sir, so like we can start writing, no, like just so that we don't have to do everything in the end.
Yes.
Yes, for every experiment, you can just write the experiment detail as I showed it before. So there are different columns. Okay, means different fields are there. You have to just fill up those different fields, and you have to send it before the next experiment. So we will actually evaluate your that write-up based on that. Okay, and as you are sending it to us, then the soft copy will be with you and with us also. So you can refer that for your future reference. Okay.
Right, sir. Thank you.
Sir. Hello.
Yes, Lisa.
Sir, we have to use only the lab manual, or we can also use standard books. This thing.
Yeah. Means it is means very much recommended that you please go through some standard books also. In lab manuals.
You can.
Yes.
Sir, you can recommend some.
I think in your theory class, your concerned faculty members, they have already recommended you, right? Any book? So your theory class that has already started, right?
Yes, sir.
And your class teacher has recommended any book for that class?
Sir, he has uploaded one book in the EC section.
Okay, okay. So then you can actually go through that book, okay? And in that lab manual also you can find very brief description about different experiments. Okay. Is
Sir,
that
you
fine?
can also upload. Sir, you can upload also some books in
Some
the
books?
EC lab section. EC
Okay,
lab
okay,
section.
okay. So in that file section, we will add some one or some books also, so you can find the link of those books from that file section. Okay, is that
Sir,
fine?
please, yes, sir. Sir, please do it today so I can refer it.
Okay, okay, sure.
Sir,
Thank you, sir.
Yes, yes, Risika.
we can start writing, right? The lab manual.
For the lab manual, yes, you can start. So, but
The first
actually,
experiment.
yes, the first experiment you can start. So, but you have to show means the experiment means you have to share your screen and then you have to show it to us. So
that will
such that
happen
we
in the
can
next
evaluate.
class.
Yes, that will happen in the next class only.
And the writing part, we have to send it to you.
Yes, the writing part is for each experiment. You have to write that experiment and you have to send it before the next experiment day.
Okay, so we have to write it on A4 plain paper.
Yes, yes, exactly.
Yeah. Okay, sir.
Sir, till now we don't have to write observation part.
Yeah, that means until you do that experiment on your own, so you cannot observe anything, right? So you can just fill up the other sections like which materials or which components you are going to use, and the theory part of that experiment. Those things you can just start writing, and the observation part you can, for now you can leave it blank, and once you do that experiment, then you can fill the observation part. Okay.
Okay, sir.
Any more questions? Okay, so we will meet on 21st, I guess, because 14 is okay. Yeah, Rizal.
Sir, one more question. Sir, is there any specific pen we have to use, or black, blue, or
Sorry,
can we use another?
sorry. Can you can you please repeat your question again?
Sir, is there any specific pen we have to use in the writing the lab?
Specific
Like,
specific what?
sir, means we have to use only black or blue pen, or we can use another pen also to decorate it.
Anything which is visible, you can use that. Okay. So there is
No, sir.
no.
Means there is no restriction on doing another writing with another thing.
Okay, so in that case, actually, you can just go for black or blue pen, because typically in our examination, we write by using black or blue pen, right? So you can actually just use these two colors also. But yeah, means there is no such restriction for that.
Means, sir, we can use the red pen or not? Not.
Red pen, yeah, you can write in red pen also. Means, yeah, that actually depends on you. Means which pen you have at that particular time. Means if you have black or blue, then please write it by black or blue. Otherwise, you can go with red pen also. Okay.
Sir, any another pen also, green pen or
Sorry, Lisa.
sir, any another pen we can also use, green pen, orange pen. Is this,
Look, actually the thing is that after you write it on your A4 paper and you send it to us, so we have to be also able to see those things and to evaluate your paper. So just please the particular ink which is visible. That's it.
Sir,
Okay. Yes, Jessica.
so do we have to write procedure?
Procedure, yes. So I will just upload the different fields which you have to write. Okay. So
Okay.
there are 7 different fields are there. So you have to just write inside those different fields, and you have to send it to us. So I will
And sir,
upload.
how long should the theory be?
That should be very brief. Okay, means that
Okay.
that should be very brief. Means there is no such restriction on that. That is just to means judge your understanding. Means how far you have understood the theory part. Okay.
Okay, so yeah.
Sir, will you provide any activation code for multi-sim?
Okay, for this multi-sim thing, we will look into this. So, but please try to find it from your side, and you can also discuss with your seniors. Is how, because in the previous batch also I guess they did the same thing. So you can discuss with your seniors also how did they do this thing. And on our side, we will also look into this. And if we get any link or something, then we will share. We'll share in this particular teams. Okay.
Okay, sir.
Okay. Any more questions?
So
okay.
the theory that has been provided in the lab manual, that's only for the help, no? Like
yes, exactly. That is only for the help, because that is written in a very brief way actually. Means you will find some terms or some things in that particular lab manual. So in order to understand those terms, you have to go to that book, any particular book. So from that book you can read, and then you can understand. Okay.
Sir, can you provide us a sample experiment so that we can be knowing that how long each section would be, like how long a procedure or any things would be?
Okay, so in next class we will do that. Is that fine?
Okay, sir.
Okay. Okay, so we will meet on 21st, I guess, because 14th is a holiday. So in between, you can just try to explore that multi-sim software, because as you are saying that you can access that free for 14 days. So you can just try to explore that, and yeah, we will meet on 21st. Okay.
Thank you, sir.
Okay. See you.
thank you, sir.